LLMs have changed the world, right? I think every one of us would agree on how the things have been changed in the last 5 years. And as a developer, it has actually changed the way we work on things, the workflow that we do, the agents that we create, the automations that we do. Everything has changed in the developer workflow, even in the HDLG lifecycle. So, in this series of building your own X, in this video, we are going to talk about building our own tokenizer. We will try and implement the byte pair encoding tokenizer in this particular video. So, without any further delay, let's get into the computer screen and let's start with the video. So, let's say we just give a simple input to ChatGPT saying hello. Okay. And we see a certain kind of response saying, hey, welcome back. What are we working today? Whether it's building a new AI full stack project, planning for coding at a video or thumbnail, or creating diagrams, visuals, etc. So if you see, the response that we got is in the form of a token. Okay. Everything here is a kind of a token. So let's understand what are tokens here. Okay. So what happens over here is, let's say we are as a user here. User says hello. Okay, I'll increase the font here, and then the response goes to slash API slash chat. Okay, the response is going to the OpenAI slash API slash chat server, and there what happens is these text gets converted into tokens. It's, or we can say, tokenization happens. Okay, wherein the entire text is converted into a form of numbers, or you can say it is compressed. So the number can be something like 33546, something like that. Okay, so that's where the tokenization happens, and after the tokenization is done, these tokens are then given to the LLMs. Okay, these LLMs could be ChatGPT, Claude, Gemini, anyone that you like. So basically, what happens is that when you give input as an hello, that goes to API slash chat, then the tokenization happens, meaning the strings are converted into numbers, and then the numbers are being given to LLM, where they process and give you the response. So before building up, or before building the entire tokenizer, these are some of the examples that I'll show you. But before moving into that, so we have our own site, which is Build X from scratch. If you are someone who wants to start learning with building things from scratch and understand what happens internally, this is the site you want to go with. And in the last video, if you've seen that we started building Git from scratch, this is now available. So your task is to just click on it and start working on it one by one. What you get here is an interactive dashboard which shows you how things are present, a project setup where to understand what things are being done. If you want to watch the video here, click on watch video. You can watch the video and parallelly learn and practice things on your way. And once these things are done, you can actually, you have an interactive terminal here. So as it says, like npm init -y, so I will say npm init -y, wrote a project package.json, everything is present here. And let's say I write npm I commander. Okay, npm I commander. Okay, I need to give it something like this. Okay, I can give it npm init -y and npm I commander. Okay, so this is something that I've been trying to build to make things work easier and make you help understand how things are working internally for different kind of projects. So you can go at build.addacoding.in to check out, and obviously you can get the source code from the GitHub repository. Build Git from scratch is also present. I've also uploaded the build tokenizer from scratch project source code on the repo. You can go and check it out and understand things. So now let's go on understanding what happens when tokenization is done. Okay, so I do have some examples of tokenizers. One is Llama Tokenizer JS Playground, and one is GPT Tokenizer. So let us give a simple sentence saying my name is Aditya. Okay, and Aditya is a software developer. Okay, so now if you go here, you must have seen that the entire thing is divided into something which is in the form of a color, right? So my is converted into a green one, name is Aditya, And in fact, for the word Aditya, it is being divided into AD, ITY, and A. So the number of characters are 49 and the number of tokens that are generated are 50. Basically, what this means is that whenever you are giving any input to an LLM, it must be a compressed input. So tokens are a way of compressing the input that we get from the user into as small as possible so that LLMs can respond it in a much better manner. So these are some different ways of tokenizing them. One is the Llama tokenizer, and another one that we have here is something we call as GPT tokenizer playground. It is consisting of all the GPT models. Okay. So GPT from GPT-5 to O4 Mini, OSS, Audio, 5 Pro, all the ones. So we can paste the same thing here and we can see that these are getting converted into tokens. Here the number of tokens are 12 and here the number of tokens are 50. So here the compression is much more. And if you see, we also get the estimated cost, like what would be the cost if you use this particular model. If we change the model, and the number of tokens may also change. And when I click on show all tokens, you can see for per character or for per word, the tokens are being defined. What is the token value for that particular word? Okay. So this is what the different tokenizers are present and how these are used. For now, what we'll be doing here is we will be trying to implement the byte pair encoding tokenization method. Let us understand what the byte pair encoding tokenization method is, and it is mostly used in the transformer model if you see. So the original byte pair encoding algorithm operates by iteratively replacing the most common contagious sequence of characters in a targeted text with unused placeholder bytes. The iteration ends when no sequences can be found, leaving the target text effectively compressed. So for example, we have the input data as AAA, B, D, AAA, BAC. Now, if you see the byte pair, double A occurs most often. It is occurring here two times and here two times. So it will be replaced by a byte that is not used in the data, such as Z. We can even replace it with Y or X, something like that. So now the following data will be like Z, ABD, Z, AB, AC, where double A is replaced by Z. Then the process is repeated with the pair AB, replacing it with Y. Now, if you see here, AB is also getting repeated, AB here and AB here. So it will be replaced by ZY, then D, then Z, then again Y, then AC. The only literal byte pair left occurs only once. And the encoding might stop here. Alternatively, the process would continue with the recursive pair byte encoding, replacing ZX, ZY with X, something like that. So this data cannot be compressed further by byte pair encoding because there are no patterns of bytes that can occur more than once. So to decompress the data, simply perform the replacements in the reverse order. So this is basically what we are trying to implement in this particular video in byte pair encoding. So now let us start building the byte pair encoding tokenizer. So as I said, tokenization is the process of converting raw text into a sequence of tokens the LLM models can understand. Okay, so now that we have the build X from scratch YouTube, we already have the build Git folder here. So what we will be doing here is we'll be creating a folder saying mkdir build um, tokenizer. Okay, and we'll just go into the build tokenizer folder. Okay, nothing is present here. For this particular project, what we are going to do is we will be first using the buffer method to just give you a very simple example of converting it in from text to bytes, and then start with the byte pair encoding method. And for this project, we will be having a simple UI, which will be a Next.js application here. So what we'll be doing here is we can say npx create next app at the rate latest and dot. So it will start creating, yes, we want to use the default methods. It will start creating or initializing the Next.js applications. Okay. Till the time it is getting created, what we'll be doing here is first we'll be defining the types here. So we'll have a folder with the name types and we'll have a file saying tokenizer.ts. Okay. Okay, our project is created. For now, we'll not start with the UI part. We'll just understand and create the different types that we need. This particular module will define the interfaces that we'll use throughout the tokenizer logic, which will help us ensure the type safety. The first thing is to have an interface, say with the name vocabulary entry. Okay, where we'll be having the token, which will be in the form of a string, along with the frequency, which is in the form of a number. Okay. Next, we'll have the interface pair frequency, which will help us define the pair which is getting repeated, as we saw on the Wikipedia page, which will be in an array of strings, and the frequency will also be a number. Next, we'll have the merge rule, which where we'll be merging the pair frequency. So interface of the name merge rule, and the left would be a string, the right would be a string, and the merged would also be a string. Okay. And next would be the training step. Usually, when it comes to large language models and we want to train on a certain set of data, that is where we'll be using the training step. And here we are using the training step to give it the number of iterations for which we need the BPE, which is byte pair encoding, to train. So we'll have the training step here. The first thing would be an iteration, which will be in the form of a number. The pair, which will be from the type of pair frequency. And the same thing would be vocabulary, which will be vocabulary entry. Okay, it will be an array. Okay. Next would be to have the interface for tokenization result. Tokenization result. So the tokens here would be in the form of a string, which is an array. The next would be the token count, which will be a number. And the third would be a character count. Okay, which will also be a number here. So what will happen using this is that these interface will help you define the shape of the data. For example, the merge rule interface here, it represents a learned rule from the byte pair encoding algorithm, like merging E and R to form ER. Okay. Next is we will be creating a lib folder, which will be a utility folder. Let's say we'll have the folder with the name lib, and then we'll also have another folder inside it with the name tokenizers. And inside that, the first thing is to create the buffer.ts file. Okay. At its lowest level, the text must be converted to bytes before a computer can process it. This particular module will help us to understand the translation using the UTF-8 encoding. So we'll have the interface here, export interface, buffer tokenization result, where we have the bytes of data, which is in the form of a number, and the binary, which is the form of a string, which is an array. Okay. And then we'll export the function, export function buffer tokenizer, and then we'll have text as a string, and the type would be buffer tokenization result. Okay. And next, the first task here is to convert the text to UTF-8 buffer. Okay. And it's very simple to do it. So we'll have a variable with the name buffer, and we'll have buffer dot from text to UTF-8 format. Okay. And then what we'll be doing here is we'll be returning the bytes where we'll have the copy of the buffer using the spread operator, and then the binary where we have the again the buffer, which is mapped with the bytes. Okay. And it will be converted into byte to dot to string, and then we'll also have a pad start here, starting from the max length as 8 and the string to be filled as 0. Okay, and we'll just do a formatting here. So what will happen over here is we'll be using the buffer method from the node to encode the input string into a UTF-8 byte array and then map each byte to its base 10 integer in the representation of bytes, and then we'll remove the leading zeros, pad with the leading zeros if necessary. Okay. Next, let us start building the BPE tokenizer. So bpe.ts. And this is a bit complex module because it will be implementing the training with the tokenization algorithm. So the training phase goes like it analyzes the corpus. Corpus means the body of a text to learn which character sequences appear the most often. So what we are going to do here is we'll have an interface, export interface, merge rule, where we'll have the left as a string and also the right as a string. Okay. And we'll also export interface with the name BPE result, where we are passing vocabulary as an array of string and the merge rule as merge rule here with an array. Okay. And the tokens will also be a string of array. Okay. The first thing here that we are going to do is splitting corpus or plus two words and characters. We are basically splitting everything into words and characters. So we'll have a function with the name split corpus where we are passing the corpus, which is in the form of a string, as an input. Okay. And we'll also have a 2D array here for strings where we are returning corpus. And firstly, what we are doing here is trimming it. Then we are splitting it. I'll have split below. Then we are splitting it. Okay. And once we have splitted it, we are filtering based on Boolean value. And then we are mapping the words that are present inside it but with the help of a copy of spread operator, and also have an end of a word token with the name W here. So what happens here is it splits the text by white spaces into words. Each word is then broken down into individual characters, and at the end of the word, token is applied or appended to each word so that the algorithm knows the boundaries of the word. Okay. Next, after we have splitted the corpus, what we do is we count adjacent adjacent pairs. Okay, so we have a function with the name count pairs where we are passing the words, which is a string of 2D array. Okay, and then it is of the type map where we have a string and also a number, and then we are calculating the frequencies of each words. Okay, and we will be storing those frequency in the map, which is of a string and the number. Okay, now we'll be looping over the words that we have using the for of loop here. So for const word of words, and then we'll have a for let I equal to 0, I less than word dot length -1, and I plus plus, and we'll find the pair. Const pair equal to, the first thing that we'll be taking would be the index of the word, and then the next index of the word of I plus 1. Okay, and then what we'll be doing here is frequencies dot set. We'll be setting these values as pair, and frequencies dot get pair, if present, get 0, get the pair, else get 0 plus 1, and then we'll just return the frequencies. Okay, so this will basically help to count the adjacent pairs, and this particularly iterates over every word and help us count the two often tokens which appear side by side. Once this is done, we'll find most frequent pair. Okay, so we'll have a function saying find most frequent pair, where we are taking the frequencies, which is in the form of a map of string and number as an input, and this will also be an input or a null value, and we'll say let the best pair be either a string or null value, and initialize it as null. Okay, and let the highest frequency be 0 initially, and then for of const pair and frequency of frequencies. We'll iterate over the frequencies and find out if the frequency is greater than the highest, then put the highest as frequency, and the best pair as pair. Okay, and then what we'll do is we'll return the best pair. Okay, now this particular function, as I said, it will identify the pair with the highest frequency that we have. So once we have splitted the corpus into words and characters, we count the adjacent pairs. Once we count the adjacent pairs, we find the most frequent pair. And once the most frequent pair is found, next is to merge the most frequent pair. So we'll have a function with the name merge words, where we are taking the words as a string of 2D array, left value as a string, right value also as a string. This particular function will be a 2D array. Okay, and next we'll have the merged token here, which will be left plus right. Obviously the token will be the left value added with the right value, and then what we are doing here is we are mapping the words dot map. Then we'll have a variable called word, which will firstly get the merged string here, which is an empty string, because for every input that we have, we'll need to have an empty string. We can't directly append it. We'll have a iteration value I as 0, and we'll loop using the while loop, saying if I is less than word dot length, if I is less than word dot length minus 1, what you need to do, and also we need to add a condition, if the word first index value is equal to left, and if the words index plus 1 value is equal to right, then merged dot push the merged token. Okay, and increment the I value by 2, I plus equal to 2, or you can write I is equal to I plus 2. Else, if that is not the condition, if I is greater than the word's length, what you need to do is merged words dot push, not merged words, merged dot push the word with the index and increment it by 1. Okay. Once you increment it, just return the merged value. Okay. Merged value. Okay. Now this will particularly iterate through the corpus and replace the left and right tokens into the merged token that we have. Okay. Next is to start having the training loop, and we can just write here training loop. So we can have a function saying export function train BPE, where we are passing the corpus as string, iterations as 10, and we'll have the BP result type here. And the first thing is to have the words here, is to first split the corpus, where we are giving the input as corpus. Next, to have the merge rules, const merge rules, not rules as merge rule, which is an array and initializes as an empty array, and then have a for loop where let I equal to 0, I less than the iterations that we have, okay, and I plus plus. And here what we are going to do is to have the pair frequency. Obviously, the first thing that we need here is the pair frequency equal to count pairs, not count pairs, where we are giving the words as an input. Once the pairs are counted, next task is to find the best pair equal to find most frequent pair with the help of pair frequency. And if we say if there is no best pair found, break the loop. Okay. But if it is found, have a left and right value or tokens here, where we are splitting the best pair into left and right, best pair plot split. Okay. And then merge it. So merge rules dot push, where we'll be pushing the left value along with the right value. Okay. And once the merge rules are pushed, so we can have words equal to merge words, where we have the words left and right value passed here. Okay. After the loop is completed, what you need to return here is first thing as the vocabulary, where we'll have a new set and we'll just have a copy using spread operator, new set words dot flat. Okay. And then sort them. Next is to return the merge rules along with the tokens here, which will be getting from merge dot flag. Okay, merge rules. So this ties the above functions together for a given number of iterations that we have. It would repeatedly find the most number of frequent pairs and then merge it, building an array of merge rules, which is like the trained model here, and updating the final vocabulary. So now once the rules are being trained, next step is to tokenize it. So we can have a tokenization phase here. So we'll have a function saying export function tokenize BPE, where we have the text as an input, which is a form of a string, the merge rules here in the form of the merge rule, and then this type would be an array of string. Okay. The first thing is to check if there is no text present, or if that there is no text dot trim, return an empty array. Okay. Then have the tokens spreaded across the text. Okay, not spreaded across the text. Start with the character level tokens here. Okay. Next, what we are going to do here is have a rule which is iterated over the merge rules, const rule of merge rules, where we have the merged value, which is a string array, initialized as an empty array, and then let have an for loop where we have let I equal to 0, I less than tokens dot length, and I plus plus. Okay, I don't think we need I plus plus here. We can remove this. And then once we have the loop here, we'll have the current value, const current equal to tokenize or tokens of the ith index, and the next will be the tokens of I plus 1. Okay. And if the next and current value equal to rule dot left and next equals to rule dot right, will push the values into the merged array that we have initialized, where we have the current plus the next, and have I plus equal to 2. Else we will do a merge dot push here with the current value here and I plus plus. Okay. After getting this, after this is done, what we'll do is have the values of the merged into the tokens and then return tokens. Okay. So this is what is happening here. What is the issue that you're getting? Okay, I need to have a semicolon. Okay, so the input text that we have here, it is firstly getting splitted into characters. The function basically applies the previous trained merge rules into exact order that they are learned, and this combines the characters into larger subwords the model can recognize. Okay, so now we will go into the page.tsx, and I'll not waste more time on creating the UI here. I'll rather give you the entire UI how it looks. Let us directly take it from the source code. We'll go here, app page.tsx, copy, because I think UI is something that we can, or you guys can learn it from your own, and we'll have this removed and call it from here. Okay, I think this is good to go. And finally, we'll do npm run dev. Okay, we'll go here, localhost 3000. Okay, so what do we have over here is that we have the training corpus, the iterations that we need, and the tokenized text. And this will initially give us the buffer representation, binary, vocabulary, everything. Okay. So we give the training corpus with the 10 iterations, like let's say we give it by 15 iterations. And the tokenized text that we'll give here is, let's say, let us even ask ChatGPT. We'll do one thing. We'll say, give me a sentence to use for understanding tokenization with the training corpus text as, we'll give the training corpus text as this one, so that it will help us understand things better. Okay, okay, we can directly use this. The low river became lower after the dry season, reaching its lowest level. Okay, and I'll just paste this. Now the first thing that you see here is that we have a buffer representation. Okay, so the entire thing is then converted into the buffers, which is like the is converted into bytes, and that bytes are then converted into binaries. So based on the conversion format that we use, this thing's changed. Since we have used UTF-8, this is how we are getting it. Okay, so this is a example of a basic tokenization that you guys can perform, where you can encode it and then return the value in the form of a decoding to the users that the way you need it to give them. And next is to have this one. This, if you see, the vocabulary here is low, lower, and lowest, where we have given the training corpus here. And these are the merge rules that it has learned. The left value is low, right value is O, and the result is LO. Left is LO, right is W, and LOW. So this is how it is training it. And this is the way we are getting the tokenized output. Because if you see here, it is basically converted into characters. Even the spaces are also taken into consideration when you want to have a tokenized output. Then we have low here, which is taken from these merge rules. Okay. Then we have lower, became, after, the dry season, everything. So if you see, the tokenized text is in the form of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 words, and the token count that we have is 63. Okay, so this is a very basic implementation of how we used and tried to implement how the byte pair encoding tokenization works. And basically, to understand the data flow here, the training model breaks down the corpus into characters, as I displayed you over here, and merges the most common pairs that are present. Users input the text that they need, then it is having a buffer tokenization to just give you the output into raw bytes and binary format. And the tokenized one, it breaks the text into characters and loops over the merge rules, combining characters into the larger subwords that we have, low, lower, lowest. And Then we get the final array of tokens which are rendered over here. Okay. So this is basically how tokenization works, and particularly it is very interesting to learn, an interesting fact to think about, that all the LLM models are internally doing the same thing. Everything is based on ones and zeros, and that's the way we get the inputs or we get the outputs, right? So it becomes a very interesting topic to understand how things are being built from scratch, like tokenizers. So this is one such video where we understood about what are tokenizers, and you can obviously check out the build X from scratch. I'll probably by the end of this video or by the next video, I'll have the build tokenizer from scratch also updated over there. So you can go and check it out and try it for yourselves. And yeah, there are a lot of things that we'll be building here. You can check out building a load balancer, backend architecture, API gateway, rate limiter. So it's like starting from the internet systems to AI engineering and then going to the backend engineering at scale. We'll be building everything from scratch over here. What I believe here in with the aim of this series is that building things will help you get your way. Okay. Building things which are actually used in the current systems, not the ones which you just build out of your own sake. Like, let's say, like building a library management system, building an Amazon clone or a YouTube clone. I think that is something that has gone long back, and it is not something that is in demand right now for all the industries present over here. And what I feel here is building things which actually help you understand the internal concepts. Like when we talked about building Git, how does Git work internally? To help you understand more, we built something from scratch. Now, in this particular video, we built a tokenizer from scratch. So this is something that helps you understand how things are working internally and helps you get a better control of the things that you want to work with. And if you're someone who wants to build your own tokenizer or in the process of building your own LLM, this is something you can watch and you can build upon your of your own. And even from this, you can build something which is much better than what I've built. And yeah, this was it for the video. If you like the video, make sure to like, share, and subscribe to the channel. Let me know your comments on how are you liking this playlist. The link for build.addacoding.in will be present on the description and the comments below. So make sure to like, share, and subscribe to the channel. See you guys in the next one. Until then, bye bye.